Good afternoon. Today we're going to do the washer method, which is closely akin to the disc method with a few differences. What we're going to do is we are going to take the region here in striped red that's bounded above by the horizontal line y equals 4, that's bounded below by the curve y equals 4 minus x squared. That would be this guy right here. You could call it g of x equals 4 minus x squared if you want to. So above by f of x equals 4, below by g of x equals 4 minus x squared. It's the region will look something like that there. That's a half strip of it's a little strip of a parabola, upside down parabola, but we've cut it off. And really it's above the parabola piece, but below the horizontal nasal piece. Note, and I went ahead. Now this time though, we're going to rotate it about the x-axis. I went ahead and drew my rectangle. There's going to be a little bit of a complication, and the complication is this. Notice here's my rectangle. I drew it in black, but in the middle I cut off the green portion. Notice we're covering some white area, and we don't want that. We want to chew out that white area and just do the red striped area. We want the volume that red striped area produces. We need to get that red striped area. We don't want this total 2x4 rectangle here. Follow my finger, you'll get a 2x4 rectangle, but we just want the red striped area and the volume produced by that red striped area. Now, okay, how do we handle the complication? So I went ahead and drew an amplified rectangle. That should be a perfect rectangle. I'm sorry if it looks loopy and like it gets skinny on the bottom. That shouldn't be the case. Here's dx. Now the total height of the rectangle is 4 in green, the number 4 here. Now the height of this little portion right here in striped green is 4 minus x squared. That's in effect what it's going to get. That's going to produce a volume that's going to get subtracted off. Is what that 4 minus x squared is going to do. So it produces garbage volume. Volume, in other words, that that's going to get subtracted off. Now, if we rotate this striped red region about the x-axis, that's what we're going to do. I mean, not rotate, revolve. I should be saying revolve and not rotate. If we revolve about the x-axis, this whole video should be revolve, then we're going to get an object that looks like this right here. It's going to be, that should be a perfect cylinder. It shouldn't be skinny to the left. I can't draw worth a dime. That should be a perfect cylinder, a non-oblique cylinder. I'm sorry if it looks oblique. With a paraboloid chewed out. This green 3D paraboloid is what the termite chews out. So it's a cylinder with an inward internal paraboloidal piece chewed out. You could think of it by a termite. And the green striped portion is what gets chewed out by this termite, or a welder, or however you want to think about it. So the entire cylinder is just the red piece, and the termite eaten deleted volume is the green striped part. Now we're going to use the method of washers to find the volume of the white portion that didn't get chewed out by the termite. We're going to do that now. So the rule for the washer method: if we have a finite region bounded above by f of x and below by g of x, on the x interval from a to b, where a is less than b, then the washer method, it looks a lot like the disc method. If a minute ago I should have said disc and not shell. We did disc last time. I've not done shell yet. But the washer method is very much like the disc method. It's sort of an extension of the disc method. But anyway, the volume is the a to b integral of pi times, notice that we introduced, it looks a lot like the disc method, but we got that minus g of x squared there. That's our garbage volume that needs to get subtracted off. And we integrate over dx in this situation. You could just as well do problems with the y-axis, but you just do it the same way, in a similar fashion. Now here's what's going on. Here's our infinitesimal washer. It's a disc with the center chewed out, where a termite has chewed the center. So now in pink I drew the entire disc. If there would have been no termite, if we would have just did if there would have been no garbage volume, then this whole pink thing would have been my volume, with nothing deleted, with no hole. Now this is my infinitesimal volume, produced by the rectangle, produced by that black rectangle. Again, we rotate it out toward our faces. If we let Z be out toward our faces, and if we let Y be up and down, and X be left and right, which is what I'm doing. So there's dx, and here's a YZ circle in the YZ plane. I can't draw 3D all that well. Now the total volume, the whole Monty, dVt stands for total infinitesimal volume. T for total equals, I just put a subscript there. So pi to r squared times h, which is the thickness. So our radius is 4. Not the diameter, but the radius is 4. So r is 4, pi r squared. That's the area of this YZ circular cross section. And then times the thickness dx. And that'll give me my infinitesimal volume of the disc. We're not doing washer yet. We're not chewing anything out yet. We're fixing to, though. Don't worry about the word washer. That's fixing to come. We'll get to this. Okay, now dV star is what the termite is going to chew out, and that's going to be this black piece right here. It should be a perfect cylinder. It shouldn't be oblique. It's just I can't draw. So the radius is 4 minus x squared, and the thickness is dx. So we do pi times 4 minus x squared quantity squared dx times the thickness, where dx is the thickness, and that's our infinitesimal volume. Don't forget to multiply by dx there. So that's our infinitesimal volume that gets chewed out by the termite. So we're going to take this black cylinder, we're going to turn it green, and we're going to embed it into the pink. So here's the same cylinder in green color, and the termite is going to chew out that center piece, that center green piece. And we're just going to be left with this 3D region up here and down here. That's going to be the infinitesimal volume that's going to be left over. And we're going to add infinitely many of these infinitesimal washers. And this is a washer now that we chewed the center out. The disc is now a washer. We're going to add infinitely many of these infinitesimally thin washers to get our object that I showed you a minute ago, namely this guy right here, the white portion of this cylinder. It's a right cylinder. I just can't draw. Okay, now the infinitesimal volume is going to consist of this and this, but not the region enclosed by the green. Okay, so in effect, we're just going to, you can think of it, we're going to subtract these infinitesimal volumes. We're going to do dVt, this guy, minus dV star, this guy, and that infinitesimal volume will be this leftover pink portion that's not entrapped by the green. So that difference in volumes is a dV of its own. Namely, it's this dV is here and here, but not inside the green piece. Okay, so now we've got that. Now we add infinitely many of those dVs and we'll get our object that was over there I showed you a minute ago. So here's what we do. So the volume is the a to b integral. You can bust up this integral. The difference of the integral is the integral of the difference. So a to b integral of pi f of x squared minus g of x squared. So remember, we're going from 0 to 2. That's our limits because of the 4 minus x squared. So we're going from 0 to 2. So the volume is a 0 to 2 integral pi. Now f of x is 4. G of x is 4 minus x squared, but we got to square the g of x. So don't forget your squarelets. And we're going to integrate that over dx. So there's the formula. And you'll just have to go through a lot of pesky algebra. Now, oops, I forgot my limits here. Let me write my limits just real fast. So that would be the 0 to 2. You just go through the algebra. And then you'll have to go through a lot of pesky algebra. I'm about to run out of time. But you'll go through all that algebra. And when it's all over with, you'll get 224 pi over 15. And that'll be the volume of the white portion of this right circular cylinder that I didn't draw so well. Okay, again, 224 pi over 15 is the final answer. After we add all those infinitely many infinitesimal cylinders. Thank you, guys. And that's all.